Terraforming Earth, the epic journey of our planet. Imagine a time when Earth was completely unrecognizable, a barren, hostile world covered in volcanic fire, devoid of life. Over billions of years, something incredible happened. Earth was terraformed, not by aliens or by some grand design, but by nature itself. From fiery infernos to ice ages, asteroid impacts to the rise of life itself, and now, human-driven climate change. This is the incredible story of Earth's transformation. We're going back in time about 4.5 billion years ago. Our journey begins with a young Earth, a chaotic ball of molten rock. Temperatures soared above 2,000 degrees Celsius, hotter than the surface of some stars. Violent asteroid impacts constantly reshaped its surface. Volcanoes erupted non-stop, spewing out massive amounts of gases, carbon dioxide, methane, water vapor, into the sky. This wasn't the air we breathe today. It was a toxic, superheated atmosphere, completely uninhabitable for any life we know of. There were no oceans, no continents, just a hellish, primordial landscape of lava and destruction. And then came the defining moment. Theia, a Mars-sized planet, slammed into Earth at the unimaginable speed of 40,000 kilometers per hour. The impact was so intense it vaporized oceans, melted rock, and shook the very core of our young planet. Debris from this collision formed the Moon, our celestial companion, born from a cataclysm. These impacts, as destructive as they were, also delivered something crucial: water locked away as ice deep within these celestial wanderers. Slowly, over eons, Earth's surface began to cool, the molten rock solidifying, the fiery skies calming. With Earth's surface cooling down, temperatures dropped to a point where something miraculous happened. The water vapor, held in the atmosphere for eons, finally began to condense. Imagine rain, but not just a passing shower. This was rain like Earth had never seen before, a relentless torrential downpour that lasted for thousands of years. The first oceans were forming, shallow, warm, and teeming with minerals leached from the newly formed crust. Scientists believe two main sources played a crucial role: volcanic outgassing and asteroid impacts. Volcanoes weren't just spewing out lava and ash, but also gases, including water vapor. Asteroids and comets originating in the colder reaches of the solar system carried vast amounts of water ice. With the oceans came a more stable climate, acting as a giant thermostat, absorbing the sun's heat and distributing it more evenly. Earth's temperature began to regulate itself, setting the stage for the next great leap forward in our planet's transformation, the emergence of life. Imagine those early oceans, still warm from Earth's internal heat, bathed in the light of a younger sun. Chapter 3. The First Life, the Oxygen Revolution. Our journey now takes us to a pivotal moment, roughly 3.5 billion years ago. In the depths of Earth's primordial oceans, something extraordinary occurred, the first stirrings of life. These weren't complex creatures, no, they were far simpler. Imagine microscopic organisms, single-celled pioneers called cyanobacteria. They were tiny, but they possessed a superpower: photosynthesis. These early microbes, bathed in sunlight filtering through the shallow oceans, developed a way to harness the sun's energy. They absorbed sunlight and used it to convert carbon dioxide and water into energy, releasing a byproduct that would change everything: oxygen. At first, the oxygen released by these photosynthetic pioneers reacted with iron dissolved in the oceans, forming rust. But over millions of years, the oxygen began to accumulate in the atmosphere, leading to the Great Oxygenation Event. This new oxygen-rich environment was toxic to many of the life forms that existed at the time, leading to a mass extinction. However, this extinction event paved the way for the evolution of new, more complex life forms, organisms that could use oxygen to fuel their metabolisms. From single-celled microbes to the rich tapestry of life we see today, it all traces back to this oxygen revolution. Chapter 4: Earth Frozen Solid, the Snowball Earth Era. Now we're going to fast forward to around 700 million years ago, a time when Earth underwent one of its most dramatic transformations. Imagine this: temperatures plummeted, ice spread across the globe, and our planet, the once warm cradle of life, became encased in a frozen grip. The ice wasn't confined to the polar regions. It extended all the way to the equator, encasing Earth in a shell of ice several kilometers thick. The exact mechanisms are still debated by scientists, but it's thought that a combination of factors, including volcanic activity and the position of the continents, led to a decrease in atmospheric carbon dioxide, triggering a runaway cooling effect. With less carbon dioxide in the atmosphere, Earth began to cool, the ice reflecting more sunlight back into space, further accelerating the freeze. But Earth, as we've seen time and again, is a resilient planet. It wouldn't remain locked in this frozen state forever. Volcanoes continued to erupt, spewing massive amounts of carbon dioxide back into the atmosphere. Over millions of years, this volcanic CO2 accumulated, creating a super greenhouse effect. Temperatures rose, the ice slowly began to melt, and Earth thawed out. This dramatic freeze-thaw cycle, while devastating to life at the time, may have also paved the way for the Cambrian explosion, a period of rapid diversification of life. Chapter 5. The Rise of Humans, Earth's Final Transformation. Our transformation brings us to a relatively recent chapter, a mere 200,000 years ago, with the emergence of a new species on the African savanna, Homo sapiens, us. Compared to the billions of years we've just experienced, the planet is just a blink of an eye. We were newcomers, evolving in a world shaped by eons of geological and biological forces, yet despite our late arrival, we possess something unique, allow us to impact the planet in ways no other species ever had. We learned to walk upright, freeing our hands to use tools. We developed language, allowing us to communicate and pass on knowledge through generations. Most significantly, we learned to control fire. Fire, a force of nature that could both nourish and destroy, became our tool. We used it to cook food, to stay warm, and to shape the environment. With the advent of agriculture, roughly 10,000 years ago, we began to alter Earth's landscape on a grand scale. We domesticated plants and animals, cleared forests for farmland, and built villages and cities. Our impact on the planet was becoming ever more profound. And then came the Industrial Revolution, a mere 200 years ago. We harnessed the power of fossil fuels, coal, oil, and natural gas. Amounts of energy that powered our industries, our transportation, and our growing appetite for energy. By burning fossil fuels, we released greenhouse gases, like carbon dioxide, into the atmosphere at an unprecedented rate. These gases are now trapping heat, causing our planet to warm at an alarming rate. The climate is changing, ice caps are melting, sea levels are rising, and weather patterns are becoming more extreme. This is the legacy intended consequence of our species' rapid rise to dominance. Utro, Earth's future, our choice, our responsibility. From its fiery birth to the rise of life and the emergence of our own species, Earth has transformed countless times over billions of years. The choices we make today, the actions we take, will determine the course of Earth's next great transformation. What do you think? Will Earth undergo another major transformation because of humans? Let me know in the comments, like and subscribe for more deep space and Earth mysteries.